Hey everyone, welcome back to my channel. Today we are diving into the world of image classification and what it is, how it will works, and how you can build your own model to classify images like a pro. So let's get into the video, okay? So let's get into image classification now. And now, before this, we are entering into deep learning. So we need to learn what are the types of neural networks. See, we have so many types of neural networks in TensorFlow, as we have discussed already about the fit for neural network. And now we are coming into the convolutional neural network, which was for the image data. And now let me consider a empty folder now and let me classify everything. Okay. And in among all these networks, we are using the convolutional neural networks now for the image classification. So let me open the new folder of see we are taking the 3pm, and then in this I have a particular data sets like see I have the images where in test, train and validation. So let me open the test. I have the five types of folders. I like five types of hero images. So let me consider these, and also in the train also we have the five and also validation we have the five. So we are maintained in this particular data set. And now let me come back and now let me open CMD, and then we have to mention the code space dot. Click on enter, and now we have a empty directory. You can able to see, right? Let me drag this. Yeah, that's good. So what I have to do now, I have a datasets. We have a datasets.zip. We can negotiate it. And now let me open the new folder, new file. Uh, cnn.ipynb. Click on ipynb. So click on enter. And now click on code. Let me test print of hi. Yeah, let me wait for a second. And now we need to import the what are the essential modules libraries. Okay, import TensorFlow as TF. And now from TensorFlow dot keras dot models import sequential. So we need to import the sequential. And then from TensorFlow dot keras dot layers import import convolutional 2D, like what are the essential required for the layers, we need to import that. So convolutional 2D, and then max pooling 2D, and then what we have to import dense, and then dropout, and then flatten. So these are the essential layers and the libraries we need to import. And then so and then from TensorFlow dot keras dot uh, pre-processing dot image import image data generator. Okay, and then import OS and import matplotlib dot patlot as plt. And now let me consider this. Yeah, let me run this. And now what we have to do, we have to take data underscore directory equals to. So from which directory we are taking the images as we are applying these things. So we need to take from these data sets, right? So data sets. Yeah, click on enter, and then batch underscore size. Batch underscore size, we are taking 32. And then epochs equals to 32, and we have to take image underscore height, comma, image underscore width equals to 128 comma 128, because whatever the images we are taking into this directory, we have to take it in particular size. Whatever the default size it will be there, we don't care. So we are taking 128 comma 128, and we are giving approach is equals to 10 only, because 10 times it will be iterating. And then why we are giving the batch size equals to 32, So let me explain this. So let me given the input images, it will check the pixels as it is representing the brightness and the color. So whatever it may be, it will detect the images. And then why we need to pre-processing the images means 128 comma 128. So all the images having the same dimensions. So it will be, and also it will be normalizing the pixels. We need to normalize by 255. Whatever the pixel value will be there, we need to scale. And then you need to understand the batch size. So I given the batch size, you have to understand why. See, if we are given the batch size equals to 32, and then approach is equals to 100, then approach is equals to C. Approach is equals to 100, then what will happen? You can able to check. See, and then before you need to know why we had to give the batch size. Then we see you actually that the convolutional neural networks will not process all the images at a time. So what we have to do, we need to minimize the images, and we need to give uh, a batches in the batches wise, so it can understand better, and it can get the more accuracy. So if we are saying the batch size equals to 32, if we are having 320 images, then what will happen? It will divide it by 32, 320 by 32, then it will be come with the 10 batches. Then it will be in each approach, it will be updating 10 times. So usually, if we are giving the 100 approaches, what it will happen? 10 updates into 100 approaches, it will be 1000 total updates it will be taken. So that's what the power of the batch size. So we must and should be process all these things, because see, if we have it 10,000 images, the loading all into one memory, it will be crash your system. So that's what we have to maintain the batch size and the approaches. So you have like so many have the doubts why you had to give the batch size. This is what the answer for this. And now previously I said we need to normalize the pixels. So that's what we have to do. Train underscore detergent equals to, see, we have to rescale, right? That's what we need to take with the image data generator of rescale equals to each pixel. Like each pixel means one. It will be 1 point. By we need to normalize with the 255. So that's what we need to rescale for everything. So let me copy this. Control C, and now test underscore detergent equals to, we need to make it same. And then val underscore detergent equals to same. That's what we need to normalize these values. And now what we have to take, we have to take a train underscore generator, generator, generator equals to, we need to take this detergent, because we need to normalize the values, right? But where we are taking, so flow from directory, which directory we are taking from. So that's what we need to check out. Now, in this particular dataset, we have the train, test, and validation. So we need to take from the train, right? So that's what I need to make it os dot path dot join. We need to join the data underscore directory, comma, train, train. And then comma, what we have to make it target underscore size. Target underscore size. We need to give the image height and image width. image width, because we are giving 128 comma 128, right? And then we need to give the batch underscore size equals to batch underscore size. What I want to say is I'm giving the batch size equals to 32. Already we fix. And then apports equals to apports, right? And then we need to take class underscore mode equals to categorical. Categorical, we need to take it. And now we need to make it three times, because we need to make it for test validation and also like a test generator and also validation generator. But what I need to make it is I need to change the test TST. That's it. Fine. And also I want to make it for the validation. We need to replace these things. Validation. That's good. And now finally we need to give the batch size equals to 32, because for the test we don't need to give the 32. Actually we can give the 1. And also we have to give shuffle equals to false. False. That's it. And that's good. Let me click on shift enter. What it will happen we can check. It will apports equals to, we got the error. So where the apports, so let me check this. So as a given apport is right, we need to remove it. Sorry. So let me remove this, and let me remove this. And let me click on shift enter, and now it was good. So we don't need to mention the approaches, that's fine. So we found 175 images belonging to 5 classes. As we already know, we have the dataset, we have the train. In this train we have the 5 types of images: first class, second class, third class, fourth class, fifth class. So we have the 5 classes of, so it will belonging to 5 types of classes. That's good, that's good. And now what we have to do is, so what we have to know, we need to know the names of the particular 5 classes. If we click on test, we are getting, but we have to get here. So train, like a train underscore classes equals to, what we have to give means train generator dot class underscore indices, class underscore indices dot keys we need to give. So let me click on shift enter, and now what we have to get train underscore classes. Let me check. So we are getting the 5 types. So we need to, why we have to give the keys means we are getting in this as the dictionary format. If we are not mentioning keys, we are getting 0 will be allogen. Like 1 will be the NVK, 2 will be the Prabhas, 3 will be the RC, and 4 will be the Ash. So we'll be getting like this. But what we want to get, we need to get the length of the, like how many types of classes we need. So we have the five classes. What we have to give, uh, num underscore classes. Num underscore classes. Because why we need to check out all these things is much things, because whenever we are giving in the output layers in the convolutional neural networks, we have to give how many types the output should be. The predictions we need to give. Every time we can't able to, like say if we have 5 types, we don't need to count manually. That's what we need to, much time should be given num underscore classes. That's good. And now we know we have the 5 types of classes. And then we need to create the model now. We need to create the model now. Model equals to sequential of, what we have to give. We have to give the convolutional tool of, we can give 32 layers in the first 32 neural networks, and then We can give 3 comma 3, and then what we have to give, activation equals to relu. Relu means rectified linear unit. And then we need to give the input underscore shape uh equals to image underscore height comma image underscore width. Why we had to give? I already said, right? We need to preprocess images into this particular shape, and then we need to give channels equals to 3 because we are giving the color images RGB, red, blue, green. That's what we need to give. And then we need to give comma, and then max pooling 2D of 2 comma 2. We need to give, and then same. We need to give the convolution 2D at least for the 2 times. Now we are increasing the neural networks 64 comma 3 comma 3, and then activation equals to relu comma, and then again max pooling 2D. It will be converting into 2D array. Yeah, 2 comma 2. Before it will be 3 comma 3, right? The 3 dimension will be converting into 2 dimensional array. And then we need to make it as a flattened because after that it will be flattened. And then what we have to do is we need to give the dense. We need to give the dense. So in the dense, how many layers we can give? 128 comma activation equals to, okay, let's see. Activation equals to relu. We need to give the relu. That's good. And then we need to give the drop out because see, whenever it will be overtrained, then we need to give dropout of 0.5. And then finally we had to give the dense layer, which is the output layer. Here we had to give how many types we have? We have 5 types, right? Then we had to give 5, but we don't need to give them manually. So we had to give the num underscore classes, and then activation equals to softmax. Why we had to give the softmax means we need to get the output in the categorical wise, right? That so that's what we had to give, and then well, let me run this. In the sequential, I'm getting a small error. Okay, I forgot to comma here, I think. That's good. If you click on Shift Enter, yeah, that's good. It will happen. And now what we have to do means we need to compile. We need to compile model.compile of optimizer equals to Adam. Optimizer equals to Adam, and then loss equals to, okay, my battery is drain out. So let me give categorical underscore cross entropy. Cross entropy. And then is the spelling good, right? Yeah, entropy. That's good. And now we have to give the matrix equals to accuracy. Accuracy. Let me click on Shift Enter. Yeah, the model.compile. And why we had to give the optimizer equals to Adam loss equals to categorical cross entropy and matrix equals to accuracy. So let me. So you already know we are given the like a dataset in this format, and then in the convolutional neural network. See, the convolution 2D plus ReLU will be getting the exact patterns, and the max pooling 2D I already said it will reduce the size and keep important features, and flatten will be converting into two-dimensional array into one-dimensional array, and then dense will be fully connected and robot like if it will be overfit, then it will be prevent the overfitting. Like if it will be overtrained, then it will become. And why we had to give the softmax? It will be get in the multi-class probability prediction. So we will be getting the prediction, the probability, and then we need to know why we have to give all these things. See, like the optimizer, uh, the loss and the accuracy why we need to give. We will check in this. And before, See, the CNN will be getting the prediction of, see, it will be extracting the patterns like edges, lines, curves, like if it will be any text, then it will be any shape like our face, like a face shapes. Then it will be getting where the face, ears, eyes, the complex patterns it will be predicting, right? And then so you need to know why we had to use the atom, the categorical cross entropy, and the accuracy. The atom will be get see it will help the model to train better and adjusting the weights. So it will get the learning speed automatically. And then why we had to use the categorical cross entropy means it will says how the model was wrong. It's predicted class probability for the multi-class problems. And the accuracy you already know like it will shows the how correct and the how accurate the model can understand. So you can see an image converted into this model and the model will be adjusted by Adam. So it will be getting the training with more accurately and it will be predicting the losses and it will be teach the losses like how we are getting the losses. So we can able to check now. And whenever we are giving the approach is equals to 10, then we can able to know whatever the accuracy, whatever the loss you can see in the upcoming. And what we have to give is model dot fit of what we have to give train underscore generator we have to give. And then approach equals to approach. And then comma, what we have to give finally is the validation underscore data equals to val underscore generator. So it will be fit into this the train generator. The train images should be fit into this particular convolutional neural networks. And we are giving the approaches. You already know how many times it will be updating for each approaches. That's what we are giving the batch size and the validation data will be checking the train data to this validation data. So it can understand the better. So we are giving the approaches equals to 10. Yeah, 10 is good. If we are giving 100, then it will be take consume more time. But it will give the most accuracy. So let me check. I'm getting 2 by 10. And you can able to notice here the accuracy will be increasing step by step and the loss will be reducing step by step. So at finally, when it will be getting approaches 10 by 10, the accuracy will be getting up to 90%. You can able to check. 75 and the loss will be come to 0.1. I think almost similar. Yes, we are getting the accuracy 92 percentage and the loss will be reduced up to 44 percentage. That's good actually. And then we are getting everything. So at last what we have to do is we have to get loss comma accuracy equals to model dot we need to evaluate. So what is see we are getting with the train and the validation. But what is the use of test? Why we are giving the test? That's what we are coming here. We need to evaluate with this test and the score generator. So that's what we'll be getting the loss and the accuracy here. So if we ask for the loss we are getting 2.05 percentage and the accuracy we are getting 0.44 percentage. But we don't want all these decimal values, right? So we have to give accuracy equals to the F string we need to mention the accuracy comma dot 2F. After I want two decimal values, that's what I'm getting the accuracy of 0.45. So if I ask for the print, then we are getting 45 percentage. That's good actually. And then what we have to do is so finally we need to save the model. We need to give model dot save of in like we had to give the extension dot h file. We had to give the dot extension of h file. You can write model dot h file. That's good. You can click on shift enter. See here the new model was created. That's good actually. And also we can save the class names. whatever the class names we are getting here, this the class, the train underscore classes, we can make it. So what we can give np dot save of, okay, we didn't import the numpy, right? Import numpy as np, then import numpy and then np dot save of class underscore names, okay, dot, we have to give the extension npy and then comma np dot array, okay, array of, you can give train underscore classes. That's good. And then the numpy class names also got saved. Okay, but we cannot getting the values, so we are getting an error. So what we are getting, one second. So np dot save cannot pick a dictionary elements. Okay, we are getting dictionary elements, right? We need to change it into this list, particular list here, or we can change there also. We can change there only. One second. You can get control X list of. We can make it like this. So click on Shift Enter, and now let me do it. Yeah, that's fine. I think. Let me do it here. One second. We will delete this. Shift it. And now cnn.ipynb. Let me do it one second. Now it's fine. Better fine. So we done with almost the model, the training the model, and now we need to go with the prediction model. So, and now see whatever we done, but we have to run all at once. So we have to delete this model dot and dot dash name h5. Second, let me run all these things. So let me click on run all. So it will make sure everything is good. So let me wait for 2 minutes. And now, until now, I will create the new file. So cnn.py. See, previously I got with ipynb, and now I'm going with .py because I want to predict the new image with the streamlit.py. So using the streamlit, let me click on here, and now import streamlit as st, and then import TensorFlow, TensorFlow as tf, and then what we have to do from TensorFlow dot keras dot pre-processing dot image and import load underscore model, load underscore model, and then what we have to import is import numpy as np. And now see, okay, we're done with this class name dot npy, and then model dot h5, we got it. And then what we have to do is st dot title, title of image, image classification, classification with cnn. That's it. Let's save this, and then we have to take the model equals to load underscore model of. We need to unload the model. What we give the model, we will unload the model. Model dot h5. Okay, let me give equals to. No, we have to maintain the brackets. In this, we have to give control X and control V. And then what we have to give, we have to take class underscore names. Class underscore names equals to np dot load of what we have to give this class names dot npynb. Let me make it rename, and now let me control all, control C, and now let me give it here in quotations. We have to give it that. Let me save this, and now we need to take ht dot, no, we had to give image equals to, we need to upload the image, right? ht dot file underscore uploader of upload a image, and then we had to give type equals to, we had to give png and jpeg, jpeg, right? And comma jpg. So in these three types of formats we can give. And now image if image got predicted, then what we have to give, img equals to, we have to take one more extension called from pill import image, and then image dot open of that particular, we have to give this image dot convert to rgb, we have to give red green blue, that what we have to convert into these channels, okay? And what we have to finally show this image, ht dot image of that particular img we can do. And before this we have to take a small image from the dataset. Let me copy this. No, we can give it some more, yeah, control c, and now let me paste it here, control v. So let me paste it outside, right? So let me give this. Before this, what I have to do, I have to run this file. So control S, control S, and now what I have to do is image equals to np dot expand underscore dimensions, expand underscore dimensions of np dot array of, what we have to do, we need to resize image dot resize of, we need to resize of what we had to give, image underscore size equals to 128 comma 128 we need to give, and then control c, control v, by 255 we need to change it. That's it. Actually, I'm doing this, but I don't want to make it in the shortest step. I will elaborate this in few steps. First of all, I want to make it as image underscore array equals to np dot array of uh, mm, img dot, what I will do is img dot resize of image underscore size. Actually, I mentioned right, img underscore size. So, and then I am resizing this image, but I want to divide it by 255. Now it was converted into image array. And now what I have to do is I'm giving image underscore array equals to np dot expand underscore dimensions. I need to expand the dimensions of this particular image underscore array. And comma axis equals to 0. We can give this 0. And why it's showing image underscore array? Okay, I'm giving img, right? Okay, sorry. Img underscore array. And now image array we got predicted. And now we need to make a prediction So we have a model, right? Predict equals to model dot predict of predict of that particular image underscore array. That's what we have to do. And finally, we need to make it ht dot prediction of prediction of 0. ht dot write of prediction of 0. Control X write of, we had to make this. Control S, and now we had to run this. Stream lit run. What we have to run of cnn.py. Click on, so it will run. So it was giving some error. So load model will be giving some error. So what should I have to do is Control C and then make it paste here. Control V and then keyrush dot. Okay, we have to write directly the models. Control C. So let me give this. Control S. And now let me refresh this. Streamlit. Yeah, image classification with CNN. And now what I have to do is I want to pick a image. In the scene, in the classes, in the 3 p.m. I want to give this image. So I could able to see the image and I'm getting the predictions. I'm getting the predictions, right? And now we need to get ht dot write of np dot argmax. We had to get argmax of prediction of 0. We had to get control C, control V, and then control S. So we can make it refresh. So we are getting the maximum prediction of allergen only. That's what the first plus. So what we have to do is, and then ht dot write of class underscore names of np.argmax. Control C, you can give it. Control S. That's it. So let me refresh this. So let me give the image. Then we can check what the answer will be. So I'm getting allergen. That's fine. This is how we can able to make the image classification with the convolutional neural networks. So that's it in this video. So we can connect in other video.